right, so what a series is, it's the sum of an arithmetic or a geometric sequence. So you're adding up all the terms that are in your sequence. Now, something that some of y'all, when you went ahead and clicked on the 10 marks assignment, you saw this weird looking notation and you didn't know what it was. What it is it's summation notation. So this weird looking E kind of letter is the Greek letter sigma. And anytime you see that in math, it means that you're finding the sum of a list of numbers. So in this case, we're finding the sum of the terms of a sequence. Let me try and explain what this means, okay? Right beside the sigma is the A sub k. So, and then on the bottom, there's k equals 1, and it goes up to n. So what this means is that this equals, you start counting with what's on the bottom. So that's going to be A sub 1. If that were something else, if that was k equals 5, then you would start with the 5th term, okay? But in this case, we're starting with the first term, and then we just add each successive term until we get to the number on the top. Well, this one doesn't have a number on the top, it just has an n. So this is just the general form. We go to the nth term. So we start with the term that's on the bottom, in this case the first term, and we add up all the terms until we get to the nth term. I've got on there how you're supposed to read it. The sum of A sub k from k equals 1 to n. We call k the index of summation. I don't know if you'll see that word somewhere. I just wanted to make sure that I mentioned that at some point. Okay? So, making sense so far? Just new notation. All right, so we can find the sum of a finite, okay? Finite means that you have a set number of terms, arithmetic sequence. If it were an infinite sequence, if it just kept going, we can't find the sum of that, because if it's infinite, it keeps going, we're just going to keep adding numbers to it, so it's going to keep growing. So we have to have a set number of terms to be able to find the sum of a sequence. And to find that sum, we've got two formulas. Okay, we've got two formulas. This first one, you may see it written one of these two ways on your formula sheet. Is it n over 2 on your formula sheet? Yeah, I think it's n over 2 on your formula sheet. I've got it written like this on the note sheet, so you might want to add this one to it. It's the same thing, it's just where's the divided by 2 positioned, but because you're multiplying, it doesn't matter where it's at. So the sum of the n terms, how many terms there are, 5, 10, 20, 100 terms, is found by taking the number of terms, multiplying it by the first term, plus the last term, divided by 2. Or, you could also look at the formula as the number of terms divided by 2 times the sum of the first and the last term. Okay? Or, if we don't know the last term, but we do know how many terms we have, and we know the first term, then we could also use this formula. But all this formula is doing is taking into consideration how to calculate the last term, okay? Because if we rewrote A sub n, remember the formula from yesterday or the day before, A sub n equals A sub 1 plus n minus 1 times d. That's all it's doing. This is A sub n right here. That's all that other formula is doing, okay? So you've got 2 A sub 1s. That's all this other formula is. So that's why this formula is not on your formula sheet, okay? Because you can find the nth term if you know how many terms, the first term, and the common difference. All right. Any questions so far? So let's use our formula. A corner section of a stadium has 8 seats along the front row. Each successive row has 2 more seats than the row preceding it. If the top row has 24 seats, how many seats are in the entire section? So we do not need to sit here and add 8 plus 10 plus 12 plus 14 plus 16 Now this one would not be that bad because you wouldn't end up having to add that many numbers, but let's look at using our formula here. So the sum of the series is equal to the number of terms. Well, we don't know how many rows there are. We don't know that yet. So I'm just going to leave that part of my equation blank. Divided by 2 times the first term, 8, plus the last term, 24. So I got to figure out n. Here's how I'm going to figure out n. I know a sub n. I know the last term. A sub n equals 24. A sub n is the last term. So I'm going to use my formula for finding the term of a sequence. A sub n, 24, is equal to a sub 1, the first term, 8. Let me write out the formula right here. Plus n minus 1 times d. Okay, I don't know n, but I know d. The common difference is 2, because I'm adding 2 seats to every row. So I'm just using the formula for finding a specific term in my sequence from Wednesday or whenever we went over that. Then I'm going to solve this. So subtract 8. 16 is equal to 2 times n minus 1. I can divide by 2. I have 9 rows. So I can plug that in to my formula now. 9 over 2 is equal to 8 plus 24. 8 plus 24 is 32. 32 divided by 2 is 16. So 9 times 16 is 144. There are 144 seats in this section of a stadium. Okay. Now again, some of these you can figure out without the formula. I'm not saying don't use logic. Okay. If you can logic your way through it, go for it. But we do have these formulas, and I'm trying to show you how to use them. Okay. All right. We can also find the sum of a finite geometric sequence. So its sum is a little bit more complicated than the sum of the arithmetic sequence. It is the first term times 1 minus the common ratio raised to the nth divided by 1 minus the common ratio. So it's got a little bit more pieces. Let's look at an example here. Find the sum of the geometric sequence. 4, negative 4/3, 4/9, negative 4 over 27, etc., 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 until we get to 4 times negative 1/3 to the 10th. So for our formula, we need to know, what do we need to know? We need to know the first term, the common ratio, and the number of terms. So first term, that's easy. That's 4. So the sum of, I'm not going to put a subscript on it because I don't know what the subscript is yet. The first term, 4, times 1 minus, what's the common ratio? What are we multiplying by every time? Negative 1/3. Negative 1/3. We raise that to the nth. I don't know how many terms there are yet, so I'm just going to leave that blank for a second. Over 1 minus the common ratio. I highly suggest putting those parentheses in there. Okay, so we got to figure out how many terms we have. Well, this is our last term right here. This is the last term. So let's think in terms of our equation from Wednesday to find the term, to find any term of a geometric sequence. Our formula was what? The first term times the common ratio to what power? The n minus 1. So what does that mean n is right here? Is it 10? It's 11. It's 11 because the result is 10. The exponent is n minus 1. N minus 1 is equal to 10. So this is the 11th term in our sequence. So we are finding the sum of the first 11 terms. Now, most people can set up the equation. They struggle a little bit with putting it in their calculator because you need lots of parentheses. Okay, so honestly, my suggestion is chunk it up. Okay, chunk it up. I would do just the negative 1/3 to the 11th first. Negative 1/3. Make sure it's in parentheses to the 11th. 1 minus that answer. Multiply it by 4. And then divide it, parentheses, 1 minus negative 1/3. Okay, to get that the sum of these terms, we'll just go ahead and say that's approximately 3. With that many zeros, we're just going to say that it's 3. Okay, so y'all see how I chunked that up. I did the exponent part up here first. I did 1 minus that number, multiplied it by the 4 that was in front, and then divided by, I made sure that bottom was in parentheses. And like I said, most people just mess up on the calculator. They set up the equation great, and that's why I need to see your work. They set up the equation great, but then when they type it in the calculator, they forget parentheses or just don't type it in right. Okay? So be careful with that. All right. Let's look at this. Find the sum of the first 25 terms of the sequence given by this equation right here. A sub n is equal to 2n minus 1. Well, they didn't give us the sequence. They gave us an equation for it. Now, looking at the equation, what type of sequence are we talking about? Arithmetic or geometric? Arithmetic. Okay, this equation right here is an arithmetic sequence. 2n minus 1 is an arithmetic. Arithmetic. There we go. Sequence. Now, you may not be able to pick out all the pieces that you need. So, my suggestion is just start writing the first few terms. Okay, a sub 1 would be 2 times 1 minus 1. So that's 2 minus 1, that's 1. A sub 2 is 2 times 2 minus 1. That's 4 minus 1. That's 3. Until you kind of see what's going on. Now, I mean, if you can pick it right off the equation, that's fine. But I'm just showing you what you can do if you're struggling with seeing it. Okay, so what do we need for our equation? We need the number of terms. Well, they told us that. First 25 terms. We need to know the first term, that's 1, and we need to know the last term. Well, can't we plug that into our equation? A sub 25, 2 times 25 minus 1, 50 minus 1 is 49. So really I didn't have to do that, but I did want to show you how you can see, okay, the first term's 1, common difference is 2, so forth and so on. So the sum of the first 25 terms is the number of terms, 25, divided by 2, times the first term, plus the last term. 1 plus 49 is 50. 50 divided by 2 is 25. 25 times 25 is it 625? That's what it is? 25 squared. Yeah, 625. Okay. Doubt myself. Okay. So again, the formula is on the formula sheet. They're going to give it to you on the exam. You just need to know how to use the pieces. All right. Let's do one that's geometric. My multiplication sign is gone there. But our equation is -1 times 2 to the n minus 1. So just based on this equation, what do we know? -1 is what? It's the first term, a sub 1. What is 2? The ratio. Okay. So let's look at our series equation. What do we need? We need the first term, -1 times 1 minus the ratio 2 to the nth. Well, first 25 terms, so n is 25, over 1 minus the ratio. Now, since this one doesn't have a fraction, it's not quite as complicated to put in your calculator. -1 times 1 minus 2 to the 25th divided by 1 minus 2 is -1. So negative 33,554,431. It's a big sum, but when you're multiplying by 2, when your common ratio is 2, those numbers are going to get pretty big pretty quick. They start out kind of slow, but very quickly they start to get bigger and bigger and bigger. So it kind of makes sense that sum ends up being so big. All right, so when you're faced with these questions, I want you to look at the equation and say, what do I know? What do I need to find out? I promise you they always give you enough information to figure out those two things. All right, we got one more to look at, because if you'll notice, there are two equations for geometric series, and they say when r is greater than 1 and when the absolute value of r is less than 1. Okay, so when r is greater than 1, when the common ratio is bigger than 1, we say that that series diverges. Okay, it diverges. To diverge means that you're not headed towards one specific point. You're headed off in another direction. Okay, but when the absolute value of r is less than 1, we say that it converges. If something converges, then it's approaching a specific point or a specific value. Okay, or to converge means to come together. All right, so let's talk about this for just a second. I always try and use this analogy. If my sequence is determined by the distance between me and the door, okay, and well, let me get a little bit closer. Okay, and if every time I take a step, I am decreasing that distance by half, okay, that would be a geometric sequence because I'm cutting it in half. So if I go a half right here, okay, and then I go a half, then I go a half more, and then a half more, physically it's going to get to a point where I can't get any closer to the door. But in theory, those numbers are still getting smaller and smaller and smaller and smaller. But they're so small that they are not going to have an effect on that sum, right? What's going to matter the most is my distance to start with, because after that point, it's even smaller, and then it gets smaller. So if I add this much to what I've already got, I'm not changing that sum that much. So if I'm adding super, super tiny numbers, they're not going to affect the sum. So we can find the sum of an infinite geometric sequence if the common ratio is less than 1. The absolute value of it is less than 1, because those numbers are getting smaller, so we're converging, we're approaching a value. And that equation is very, very simple. It is just A, which A is the first term, that should be A sub 1, okay? A is the first term, A sub 1 over 1 minus R. Put a little subscript there. I was like, what is A? A sub 1, first term, divided by 1 minus the common ratio. That's all it takes to find the sum of an infinite sequence, geometric sequence. When R is less than 1. You can't use this if R is greater than 1, because your numbers are going to keep getting bigger and bigger and bigger, so your sum is going to keep getting bigger and bigger and bigger. Does that kind of make sense? Okay. I was getting some confused looks, so I just wanted to make sure. All right, so let's look at this. We've got to decide whether it converges. If it does converge, let's find its sum. All right, so let's look at the equation and zoom in on what the important part is. This is the important part right here. 0.75 is the common ratio. So that is less than 1. So this one converges. So we need the first term and the common ratio to plug into our equation. So the first term, this starts at k equals 1, so plug in 1 into the equation. 1 minus 1 is 0. Anything to the 0 power is 1, so our first term is equal to 3. So the sum is equal to the first term, 3, divided by 1 minus the common ratio, 0.75. So 1 minus 0.75 is 0.25, which is 1/4. 3 divided by 1/4 is 12. All right, let's look at B. It doesn't have anything in front. It just has a number raised to the nth power, so that number is our R. -4/5 is less than 1. Notice this one starts counting at n equals 0. Okay, so that means we need to plug in 0 first to find our first term. So anything to the 0 power is 1. So on this one, the first term is 1. 1 divided by 1 minus the common ratio. Subtracting a negative, same as adding a positive. 1 plus 4/5 would be 9/5. 1 over 9/5 equals 5/9. Yes, I expect you to be able to do stuff like that without the calculator. It's the expectation. It's not necessarily required. All right, let's look at C. Does C converge or diverge? Diverge, I hear diverge. Okay, check it. Pi divided by 2 is greater than 1. Okay, so I threw this one on here because people love to say that when there's whenever it's something less than 1, they want to just say that if it's a fraction, they want to say if it's a fraction, then it converges. Well, it's not just if it's a fraction. This is a fraction, but that fraction is greater than 1. So you have to be careful with that. You have to say that it's just if the number is less than 1, not necessarily that it's a fraction. All right, so that one diverges. We cannot find the sum of that infinite series. If there was something other than infinity up here, then we could find the sum of the finite series, but we cannot find the sum of the infinite series. All right, last one here, 1 plus 1/2 plus 1/4 plus 1/8. It's not given to us in equation form, it's given to us in sequence form. Is our common ratio less than 1? Yes, what is our common ratio? 1/2. We're multiplying by 1/2 every time. So the sum is equal to the first term, in this case is 1, over 1 minus the common ratio. Common ratio is 1/2. 1 minus 1/2 is 1/2. 1 over 1/2 is 2. So it's a little bit on the mind-blowing side that if I add 1 plus 1/2 plus 1/4 plus 1/8 and every other fraction after that point, when I'm multiplying by 1/2 to get those fractions, if I add all those numbers up, it's only going to equal 2. But it is. You can do it if you want to. You can sit there for a while and type in numbers and keep adding them, and it's still going to end up just equaling 2.